Right, so this is the last video of integration, and we're going to be looking at modeling. So it's just a matter of just piecing all together, all the previous videos together. So they're going to give you like an example of a model, and you're going to have to create your own differential equations and then integrate it using the methods or all the methods we've learned previously, and then finding our general solution and the particular solution. So let's take a look at this example here. So we have in figure 2 a cylindrical water tank. The diameter of the circular cross-section of the tank is 6 meters. Water is flowing into the tank at a constant rate of 0.48 pi meters cubed per millimeter. At time t minutes, the depth of the water in the tank is h meters. There's a tap at the bottom t at the bottom of the tank. When the tap is open, the water leaves at a rate of 0.6 pi h meter cubed per millimeter. Show that t minutes after the tap has been opened, this differential equation. Right, so we've learned in chapter or in the differential equation part in differentiation that we know the rate, right? So the rate, they told us some rates. They've told us that there's a rate of water going in, and this rate of water is 0.48 pi. They've also told us that when the tap is open, some water is flowing out, so that's going to be a 0.6 pi h. That's the rate of water flowing out. So we can see that the rate of water flowing in and out, dV by dt, is going to be 0.48 pi, so it's positive because it's increasing the height, and then it's leaving, so it's minus 0.6 pi h, like this. So this is our dV by dt. We're trying to find dH by dt, so we need to form that. So dH by dt is going to be equal to dV by dt, because we know this, multiplied by dH by dV. So we just need to find dH by dV, meaning we need to find an equation of V in terms of H or H in terms of V. Luckily for us, it's a cylindrical tank, so we know this volume of a cylinder is pi r squared h, meaning that dV by dH is going to be pi r squared. And because the radius is, or the diameter is 6, the radius is 3, this is going to be equal to 9 pi. Right, that means we can say that dH by dt is equal to dV by dt, which is this term here in the beginning, so 0.48 pi minus 0.6 pi h. We found dV by dH, so to find dH by dV, we just flip it, i.e. just divide it by 9 pi, which means we'll cancel out, cancel, and you're left with, if you rearrange, then you'll be left with what they want you to find, like this. So that's how we form a differential equation from a model, from information that they're giving us. Now in part B, they said, when t is 0, h is 0.2, find the value of t when h is 0.5, meaning that we need to create an equation of h in terms of t, so we need to actually solve this differential equation. So like the previous video, we need to bring all the h's to one side, all the t's to the other side. And as I said before, we can't subtract or minus or plus or minus, so in this case, what I have to do is divide the whole thing. So I divide 1 over 4 minus 5h. That's the only way I can bring it to the left-hand side, dh. And I divide 1 over 75 to bring it to the right-hand side with the dt. And now it's just a matter of integrating it. So this one is going to be negative 1 over 5 ln 4 minus 5h. And that's going to be equal to 1 over 75 t plus c. Now we need to find, this is a general solution because we have to see, we need to find the particular one, and they told us that when t is 0, h is 0.2. So when t is 0, h is 0.2, which I can plug in to find my c. So we're going to have minus 1 over 5 ln 4 minus 5 times 1 over 5 for 0.2 is equal to 1 over 75 times 0 plus c. So we have minus 1 over 5 ln, this is 4 minus 1 is 3, and that's going to be our c value here. Right, so I can now rewrite it. Well, now they're asking us to find the h value, or t value when h is 0.5. So I can say our equation is 1 over 5 ln 4 minus 5h is equal to 1 over 75 t minus 1 over 5 ln 3. And they're asking us what is t when h is 0.5. So I'll just plug it in to get my t. So we're going to get minus 1 over 5 ln 4 minus 5 over 2 is equal to 1 over 75 t minus 1 over 5 ln 3. This here, if I'm going to bring, so it's going to be 1 over 5 ln, this is 3 over 2. I'm going to bring the c part to the left-hand side, so we can get plus 1 over 5 ln 3 is equal to 1 over 75 t. ln's are log, so I can combine them together, giving me ln, this is going to, well, 105 ln 3 divided by 3 over 2, so it's going to give me 2. That's equal to 1 over 75t. So therefore, t is going to give me 15 ln 2, like this. So as you can see, it's just a combination of all the different integration techniques that we've learned and creating the differential equation, solving the differential equation, and so on and so on. So that's the end of the integration video series. In the last video, we're going to be looking at more difficult integration types. I'm going to go through some past paper exam questions and just so that you guys can follow along or we can solve it together and just pinpoint or give you some tips on when trying to solve these types of questions.